So one thing to know about disease, in some ways, you come into farming and gardening expecting disease. But it's not meant to be some kind of manifest destiny that the plants will be subject to disease. I mean, late blight is a reality out there. But on the other hand, nature has ways of dealing with it, and we have ways of doing something more with it. So in order to take on disease, ideally, we're doing everything I was talking about in the first part of this class, but we have to learn a few basics about those diseases, where they come from, what they are, what we might do to influence things in our favor. But in terms of humans and understanding all this, it's mostly invisible. And out of that invisibleness comes fear. And particularly when you're farming for a living, you can get really easy to bring out the sprayer and put on the copper and sulfur, because you don't see the ramifications of the infection until later. So where did it come from? What's going on? Fungal diseases. As you start to look into spores and conidia and understanding the reproduction phases of fungi, knowing that when it rains in spring and the leaves on the ground of the orchard get wet, that hundreds and hundreds of thousands of spores are released and they land on your fruit and on your leaves. What are you going to do about that? I mean, you can look at it fearfully and you can look at it with understanding. We're going to get into the understanding. So first thing to understand about fungus, they're not all diseases. I mean, we've talked about the mycorrhizae, this very important ally, the saprophytic fungi that break down organic matter. When we choose to spray fungicides, we don't just impact disease, we impact those good things on the surface of the soil. And that really knocks us back in terms of plant metabolism. Then there are the arboreal fungi. So anyone who's ever fermented the fresh juice of the apple and resulted in hard cider, well, you didn't need to add yeast because it's already on the surface of that plant. When you talked about the mashed fruit in the compost tea, that does sound like the yeast component of that. There's also the shelf mushrooms. There are epiphytic fungi who, you take the bark off of a tree, they grow up between the cambium layer with their hyphae. And a lot of that we don't know about. So that's a whole nother grouping, this notion that on the surface of the plant, connecting to the ground, are other fungi. And then finally, there are the disease fungi, the pathogens, the parasitic fungi. But they're just a portion of the picture. We're going to look at that portion now, but we're going to remember the rest. So this notion of facing our fungal fears, again, is launched by understanding what's taking place here. For humans, finding materials that would have some applicability to disease began as an accident. And that accident was in France, and French grape growers were just disgusted by the people walking up and down the road. There's the road and there's the grapevines on that fence, coming in and picking the grapes. They weren't buying the grapes, they weren't doing any of the work. And so out of their disgust, they just sprayed them with copper sulfate, made them all blue. And people didn't want to eat the blue grapes, but also they noticed that, hey, that knocked back this disease. And this launched our whole approach to finding some material to toxify, take care of the disease. And we went on from there to learning about sulfur, learning about the EBDC fungicides as we developed the chemistry coming out of World War II. And that thinking that goes with that kind of approach is where we basically have just been hovering for a long, long time. And it really comes out of what I call the clean slate mentality, this notion that disease organism, let's just wipe out the organism so there's no problem. We do that with our medicine. Antibiotics, which have a great role to play in maybe 1 out of 10 instances, we go to way too often to wipe the slate clean. When you wipe the slate clean, in the case of being put on antibiotics, if you happen to go into the hospital at the same time, you are set up to catch disease. Similarly, when we wipe the slate clean by using organic sprays like oxidate, which has a place, or we use the chemicals, it's not just the good guys, but it's not just the bad guys, but good guys are wiped out as well. But this is that kind of thinking we're coming from with fungicide thinking. And it's naturally done. To take it a little bit further, we have to understand a little bit about the specific disease that we're being challenged by. So let's just take apple scab. Apple scab is something that overwinters on the fallen leaves. In the fall, goes through a reproductive stage where it forms pseudothecia, which are the spore stacks that when the leaf gets wet in the spring, will release those spores by the hundreds of thousands. And there's a time when the apple tree, the apple leaf, is most subject to being infected, and a time when it's able to be too old to really get that infection. But if it gets it during what's called the primary infection window, that time when it's most subject to infection, then there can be a secondary cycle. And then the scab lesions on the leaf in the summertime produce conidia, which does it again and again. So if we don't keep it in check in the very beginning, it can get really worse throughout the summer. And that whole business is one, telling us where it comes from, fallen leaves, and also when it's most likely to happen, when we maybe need to do something, because we looked at its life cycle. And those are the two key aspects: the launching pad, where does it come from, and the timing of when infection is most likely, when we need to do something more than just hope that our ecosystem advantage, our soil biology is doing the job optimally. And for different diseases, it shifts. So when you talk about brown rot, we have a couple different launching pads, and we have a couple different timing windows when something might need to be done. So brown rot is something that overwinters as a twig canker, as a mummified fruit, as a mummy that's on the ground, particularly where it's not that biologically active and things get broken down and decomposed. So that's where spores are going to come from. And the first round of infection is going to infect the flower clusters, and the base of those flower clusters, the spur wood. And that's where you see the brown withered bloom that comes off. You come out of bloom time and you see some clusters of brown withered aspects. At the base of those brown withered parts of the tree, there is a new canker that's formed on the shoot. That new canker is going to produce the spores that actually rot the fruit. So there's a point in the season early where we need to do something about preventing the brown withered bloom so that those cankers on the shoots don't form to then get the fruit. And that business of getting the fruit, it gets worse and worse as we get closer to the fruit being ripe. So that's an understanding of the launching pad, and also that there's two timings. There's not just one, as in the case of apple scab. And each disease has a little bit of nuance to it that changes a little bit. So if we added cedar apple rust, that lasts longer than apple scab in terms of the infection period. But again, it's about understanding the specific disease you want to talk about. Sometimes people don't like lots of information. But without going into that little bit of depth for what you're dealing with, you're not going to understand it to justify the actions that might be required. And again, with scab, prevent the first round, you don't deal with secondary scab. And that makes a huge difference. So we begin all this with pink. I'm talking of blossom, the bud phases of the tree. And this is a moment you always should really savor, not just because the flowers are so beautiful, but because everything goes downhill from here. The pests come on, the diseases come on. One of the things about disease is that lag time. And knowing that scab doesn't appear till 7 to 9, sometimes 14, 16 days later, is one of the bits of information I use to analyze how I have approached working with scab. When I've timed sprays, did I need to do it? So you're not going to see it right away. This is work done by various extension scientists where they were looking at what are the factors that come together when scab is most likely to happen. And one of them is that leaf tissue that is 3 to 9 days old is the most susceptible to infection. So that's why early spring, when shoots are extending and expanding, we have that first flush of shoot growth going into bloom and during bloom, then that pauses, and then at about 2 to 3 weeks after petal fall, the shoots start growing again. Well, that shoot start growing again is another big scab moment because that's young tissue. So young tissue is part of what's going on here. Another factor is early spring, buds pop. There's not a lot of surface area for spores to land on. Once the tree has grown up and filled its canopy more, there's a lot more target. So that becomes a factor. And then finally, the spores aren't all ready to go as soon as winter ends. They need to go through a maturity process, and that takes the accumulated warmth of the sun. So one of the ways that we track that accumulating warmth is what's known as degree days. So there's a saying, 100 years ago they didn't track degree days per se, but they had sayings. And one was, don't plant your corn until the oak leaf is the size of a mouse's ear. Well, that wasn't just superstition, that was because the oak leaf comes out, one of the last trees to come into leaf, and that means that the soils are warm enough for the corn to germinate and not rot. So that was all about a way of thinking about degree days without using that terminology. Today, we can track certain events, the pace of their development, by keeping tabs on minimum and maximum temperature each day. So early spring, and it's a warm spring day, it gets to be 60. At night it drops to 40. Add those together, 100 divided by 2, the average temperature was 50. So scab has a developmental threshold of 32 degrees. So on this particular example day, 50 minus 32 is 18 degree days. And this is something that you start to track once buds break open. So you're going to be able to forget all this in just a minute, but this is the thinking that goes into it. At about 300 degree days, there is, and this is about the time when the tree is at what would be called open cluster, early pink. So these are bud stages again. You know, I don't tell you that this happens on April 30th here. It happens at a different pace in different places, but the bud stage is also subject to degree days. That's the point when all these factors, spores maturing at a different pace throughout the orchard, leaf surface, and young tissue come together. And until about 700 degree days, the risk is greatest in that window. And 700 degree days is about a week after petal fall. And that's when shoots start to grow again. So it's during that period, that's what's known as the primary infection window for scab. And that's when we maybe need to do something depending on our goals and the varieties that we're growing and the pressures we're subject to. So another part of a fungal disease is that when a spore lands on the leaf, that doesn't mean it's infected. That spore in turn has to produce certain enzymes to send out its hyphae to penetrate a cell on the leaf in order to cause infection. And for that process to happen, it has to stay wet long enough. So more work was done along this line. So at 50 degrees, it takes 11 hours of continuous wetting for that infection to take place. And there's some other factors involved here as well in terms of that length of time. But understanding that it takes a certain amount of wetting before disease takes place leads to some other things to think about. One of those is planting your fruit trees in a site where there's some good drying breezes. And we all don't have the ideal site, but it's not locked in on all four sides by trees and buildings so that there's never any breezes. Another thing is how we prune. You know, there are various reasons that we prune to renew fruit buds, but another big part of it is sunlight penetration, and with that is also openness so that things dry out quicker. So a really dense tree, it's not going to dry out as quick. It's more subject to getting a disease because we don't have that advantage of drying out. So sometimes the way the rains happen, the weather happens, it's very favorable and scab doesn't get a foothold. So that's why some years wild trees seem to be like great, but it really has to do with the conditions. So in organics, 3 materials were developed over the decades to deal with it. One is copper, and copper is something that I might use in a certain transition situation or a high pressure situation, but mostly I know it's bad for the microbes and bad for the earthworms. And copper, when you use these materials, you think you might need to use them, you need to understand how they work. And copper works like this. You're a fungal pathogen walking down the sidewalk, and you walk in front of a 4-story building, and up on the top of the roof, someone drops a blue piano over the edge, and it smashes you. That's how copper works. It just obliterates life. So excess copper can be rarely can be a useful tool, but it can be a tool. Sulfur works as a protectant in that it changes the acidity of the moisture puddle on the leaf surface. So when I talked about spore landing, creating enzymes to send out a hyphae, a more acid environment makes it harder for that spore, in the case of apple scab, to send out to create those enzymes. So sulfur basically burns out the process by which the scab might get infected. But it needs to be in that moisture puddle to begin with, or at least at the end of the wetting period. And then there's another material called lime sulfur, which is polycalcium sulfide, or something along those lines. But it was the combination of hydrated lime with sulfur that created a liquid formulation that can actually penetrate into leaf tissue and burn out a developing scab lesion within 24 to 36 hours. Now, it doesn't only do that, it has an impact on the amount of fruit that stays on the tree, it has an impact on return bloom, it has an impact on things like predator mites that keep mites in check. So it works in one sense, but it causes ramifications in another sense. So this is all allowed in an organic certification orchard because they're natural mineral fungicides. And they have different attributes of how they work. And I have not ruled out using them in some settings, particularly transition settings, but there's a way to get beyond them. And just again, understanding there's ramifications here. So I'm going to look at a few examples of when I might use them. If you have a bad fire blight, many fire blight strikes the season before, and you might do some pruning. We can talk about how you approach fire blight. Well, it's very likely you have an orchard now with a lot more excess fire blight loading. And when we talked about those cankers, I don't know the right word for this, when they're disseminating more bacteria early in the spring, fire blight is a bacterial disease that any bacterial disease requires an opportunity to get into the vascular system of the tree. So that opportunity comes when a blossom opens. That opportunity comes when hail tears open a leaf. That opportunity comes when aphids or leaf hoppers chew on the ends of a shoot tip. But until those opportunities come, fire blight can't get in there. So in this early spring, fire blight spreads, but it doesn't cause infection. And the use of copper in that setting throws all these blue pianos into the crevices of the bark where fire blight is building. So that can be one example when you might use something because you know you have a bad situation that's gotten out of hand. You don't just do it automatically every year. It's kind of tied to what's the reality at your place. So similarly with the whole thing about rot, this is about understanding these two phases. This is another time early in spring if brown rot, and maybe down here this is something you do more yearly without much of a break, where copper can be useful on brown rot early on at that moment of buds starting to swell and just coming into flower. An application of 2 of copper may help clean up the first phase so you have less of the second phase.
Michael, is it important when you're using copper, which I've never had, but I've had reason like you're describing to maybe use it to not let it drip off? I mean, is it advisable to try to just use it lightly so you don't get drip into the ground, or is it?
So I find by hardly using it, like I used it once this spring because I had brown rot last year because it was so wet, and that's unusual for us up north. But I didn't mind it dripping because copper is something that my soil is not really high in copper. But now if I use copper regularly every year and 4 times a year, I'd start to get concerned about that. And that would show up in a soil test. You're getting higher and higher copper levels.
And disease resistant to it.
Right. Yeah, things shift. So another disease is cedar apple rust. Now this one has a cycle with the eastern red cedar. And it's something that one year it's on eastern red cedar, the next year it's on apple. but there's 2 rounds of it, so every year it's on apple, it's just a different sink. So it goes back and forth, and there's an infection period on the apple tree, but there's no secondary cycle. And that infection period lasts a little bit longer. Cedar apple rust appears as the orange dot lesions on the leaf. So some of you might have seen this, some of you might not be dealing with it. And it's the proximity of those eastern red cedars that can make the problem a lot worse. And it can go on to the fruit. So one of the first things you do here is just be aware of some resistant varieties. Anything in the Macintosh family, which has a scab problem, has an ability to resist cedar apple rust because the cells that get infected self-destruct. And then there are disease-resistant varieties like Williams Pride and Liberty that have resistance to rust and scab. So that kind of thing, making the choices if you're having a serious problem with that, can be really helpful. Then there's an apple called Akane, which is a Japanese variety that has a broad resistance mechanism to a number of diseases, and it's really a spectacular flavored apple. Is anyone growing Akane? That's one just to grow because of its flavor. I mean, it's really, really good.
How do you spell it?
Akane. So anyway, there are rust-resistant varieties if that's an issue, which can be a big leg up if you're dealing with it. But another thing that's out there is, as we get into talking about enhancing the immune function of the tree with holistic sprays, I'll be talking about certain compounds that are that immune function. And one of those are the terpenoids. And this is kind of a homeopathic idea. It's the needles of the eastern red cedar of any conifer are rich in terpenoids. And a tea of that particular plant, which causes the disease, or is involved in the disease, is probably a likely part of the cure. So it comes down into that plant science. Now, another thing that's different about cedar apple rust, I just wanted to point out, is that where scab is subject to the acidity of sulfur in the moisture puddle of the leaf, cedar apple rust does not like it to be alkaline. So it's the opposite of scab in this respect. And so here's where baking soda or things like potassium bicarbonate, there's commercial products, comes into play. But again, I'm just throwing these out as examples that you have to know your disease to understand certain parts of what's going on.
So if you have cedar trees that have that disease on them, you, I guess, have to get rid of the cedar trees.
That is a really good approach. But it can blow in from as much as 2 miles away, so you have to become a land baron to be able to afford to, or really get along with your neighbors.
Everybody else's cedar trees too.
Right. But that's not necessarily something you can do. You know, you have that neighbor and they don't want to cut the cedar. And the cedar has a place too, so I shouldn't really pick on it. Another thing, nickel, the micronutrient nickel, has an effect on the rust disease, and this has to do with the way it stimulates the immune function of the plant. But these types of things, again, tie into what's the disease, there's its launching pad, the cedar tree, and then what kind of action is it subject to? Acidity, alkalinity, subject to how can we boost the immune function of the plant. Peach growers are subject to something called peach leaf curl. And here the nuance I want to point out is this is a fungus that overwinters in the bud crevices of the tree. And so it's pretty protected when there's a leaf growing on the bud end. But when the leaves fall off and fall, that bud crevice is exposed. And so peach leaf curl is something that is subject to either lime sulfur or copper. So if you have a really big problem with this, that's the opportunity to knock it back, because when the leaves come off, the bud crevices, the bud scales are exposed. And that's all about knowing where it overwinters. That's its launching pad. So it still comes back to what's the launching pad, and then what's the period when it's most likely to cause infection. Black knot, there's a cherry tree out here with incredible black knot, more incredible than I've ever seen. This is something where pruning it out in the early years can help. This is something that comes from the wild cherry species. Not all cherries are subject to it, so you have a choice of the varieties that you might want to grow. Knowing that the spores are going to be released 2 to 3 weeks after bloom. Black knot's not coming on early in the season. So now we're growing some stone fruits, talking about stone fruits, and some of the dynamics shift, but it has to be based on what have you experienced and then learn when's that infection period, when do you need to do things. Fire blight, we briefly have already mentioned. There's a number of other bacterial disease on stone fruits. Bacterial spot would be one of the big ones. But again, any bacteria requires an opportunity. This is a completely different thing than the fungus. The fungus, it's wetness and enough moisture time. With bacteria, it's an opening into the vascular system of the tree. So like if you're growing pears, there are more resistant varieties, or varieties that might get struck by fire blight but recover from it. Then there are varieties that just totally melt down and become black and die. So don't bother planting the ones that we know have that kind of problem. Being extremely aware, if you see blossoms that get moist and turn black, and you need to go out and snap those off so that the bacterium doesn't move deeper into the vascular system of the tree. If shoots get that shepherd's crook, you need to come out and prune those shoots out below where the infection appears. And sometimes that means making a cut that's not at the thinning juncture, but more of a heading cut. And knowing that that had blight, I often would mark those cuts that I leave like that. That's called the ugly stub. And if you come in the winter, so that point where you made the cut, that's an opening into the vascular system of the tree. So fire blight's right back on it, but now it's not infected and causing it to blacken. It's just going to be there for the next year. When you come and remove the ugly cut when it's wintertime and it's cold, the infection isn't going to reoccur. So that's another kind of a two-step process. I do a lot of cutting off of my arm, I could get into this. Then there's the copper. I've already explained how that works as lessening the launching pads. It doesn't work to spray copper on the blooms. It's a different dynamic. That's the copper blue piano being thrown at the dormant bacteria. And one of the ways that growers have been dealing with fire blight is with antibiotics. So that comes out of the microorganisms, but we've synthesized those antibiotics, and they're sprayed on the open bloom so that when the bacterium lands in there, it's subject to that action. And just as of this year, antibiotics are not going to be allowed in organic production. And that's not a concern whatsoever, because all we have to do is think a little bit deeper. And it's the fact that an opportunity exists on that open bloom because it isn't colonized by other species. And so there are products now, things like Blight Ban, which is a Pseudomonas bacteria, and Blossom Protect, which is a yeast organism, that you can spray on the open bloom and crowd out the pathogen, prevent the disease from happening. And some of those organisms will produce antibiotics. That's where true antibiotics come from. So we'll kind of hit on that a little bit more as we go deeper into this holistic approach.